Okay, I hope you can see the screen now. So we are going to continue section 3.1 today. That is how to use the distribution function method for bivariate case. Okay. So we consider, again, you can remember that the distribution function method is applicable only for continuous random variables. The reason is after we find the CDF, we get the derivative of the CDF to get the PDF. That is only possible with continuous random variables. The integrations and derivatives are possible with continuous densities only. Therefore, the distribution function method is applicable for continuous type of random variables. Now, in this course, we are looking at 4 special functions only. Okay. Maybe you can extend this to linear combinations of these functions, but we are mainly looking at the sum of 2 random variables, that is x plus y, the difference of 2 random variables, x minus y, the product and the quotient, where y cannot be 0. Okay. You can change these variables okay, with other letters, that is fine. Now, if you want u equals y divided by x, that's fine. These are just the letters and notations. Okay. So let's look at one by one how to find or derive the density functions of the sum, the difference, the product, or the quotient. I have already shared a document with you, the proof of distribution function method. Now it contains some examples also. It is a little bit abstract type of proof. So I will explain this proof step by step today. Okay. So first, let's start with the u equals x plus y. Okay. Now, whether it is x plus y, x minus y, the product or the quotient, these are the steps we have to use. Okay. So I'll start with the steps first. Okay, when you have these sums, differences, product and the quotients, it is always easy if you use the region or if you draw the graph. Okay, so as the first step, you can find the region where our new random variable u is in xy plane. Okay, in your Cartesian coordinates, you should be able to find where the region lies for u. Okay, depending on x plus y or x minus y, you can easily find the region of u. Okay. So after you find that in your xy coordinates, you can write the CDF. Okay, you have to find the CDF of u, okay, which is capital F u. You do this by integrating the joint density, which is fxy, over the region u from its lower limit up to any u value. Okay, in order to find this region, it is easy if you use the graph. Okay, from the graph that you found in step 1. The next step, after you find the CDF, now you know what to do. You can find the PDF by differentiating. Your CDF, you differentiate it with respect to u. So you will end up with the density function of FU. Okay, so this u will be either x plus y, x minus y, x times y, or x over y. Okay. Now, when you do these type of questions or examples, it is very important that you identify the region. Okay, in any case, the region is important. Now, in this case, depending on the region of x and y, you have to find the region of u in the correct manner or in the proper way. Okay. Now, this can be done with respect to y or with respect to x. Okay. Now, depending on whether it is the sum or the difference or the product of the quotient, sometimes finding the region with respect to y is easy. Sometimes with respect to x is easy. So you will see when we do these proofs, sometimes we use or we do the integration with respect to y. Sometimes we do it with respect to x. It is not that because it is the only way, but it is the easiest way to explain and to understand. Okay, but not that you can do it either with respect to y or x. Okay, but when you find the regions, it is sometimes easier if you stick with only x or y. So depending on that, sometimes I will be integrating with respect to y, sometimes x. Okay, that is simply because it is easy to understand, and for you also it is easy to do these steps. Okay, but you can do the other way around also. Anyway, so let's start with the first one, which is x plus y. So if you have read that proof, maybe you also have a little understanding about what we are doing. Okay. So here's the first one. X is, sorry, u is x plus y. Please give me a minute to change the color of the pen. I'm going to stop sharing the screen for a while, but I'll come back, okay? Okay. And so we're going to look at u equals x plus y. Right. So our goal is we need to find the PDF of u. where u is x plus y. Okay, so let's start with finding the region. So we need to find the region where this u, the random variable u, is less than or equal to any value simple u. Okay, so capital U is the name of the random variable. Simple u will be the values that capital U can hold. Okay, so what is our u? It is x plus y less than or equal to u. Okay, so u is x plus y, so we replace capital U by x plus y. Now in this case, we are going to do these steps or integrations and differentiations with respect to y. Okay, so if you isolate y, this will become u minus x. So y is less than or equal to u minus x. So this is kind of now if you think about the inequality, now change this to the equal value. Okay, how do you write the equal? That will be y equals u minus x. Okay, so you can see that this is the equation of the straight line. Okay, equal the equation of the straight line. The slope is negative. The m or the slope value is 1. You don't see the slope here, okay, or a number here, so it is 1, and the y-intercept is positive u. Okay, now can you try to draw this line on your xy coordinates? Y equals u minus x. How do you do that? Okay, so if you draw the xy coordinates, here's our origin. Okay, so when you have a negative slope, you have the line going like this, negative slope with positive y-intercept. Okay, so what is the, can you find the points where this line, so this line is what? Y equals u minus x line. Okay, so this is the line. Now can you find the coordinates of these 2 points? What are the coordinates of these 2 points? You have the origin 0, 0. Can you find the coordinate of this, the first point, which is where the line crosses the x-axis? What is the coordinate of the point where the line crosses the x-axis? Okay, you know how to find it. Substitute in this equation when x is, so what will happen when the values are 0 and so on? You know how to do that, right? So that will be u comma 0, right? So that will be u comma 0, right? In the same manner, can you find the point, the coordinate where this line crosses the y-axis? That is when y is, when x is 0, what will happen? This is when y is 0, right? So you'll end up with 0 u. Yes, Aravinda, that's correct. So you'll end up with x is 0, and at that time y will be u. So you know the 2 points. Okay. Now what will be the region? Now this is the equal sign. The line is y equals u minus x. So what will be the region which satisfies this inequality, y less than or equal to u minus x? Is it the bottom part or the upper part? So I'll write, is it region 1 or 2? What do you think? What is the region that satisfies y less than or equal to u minus x? Region 1. Okay, region 1 means everything below this line, and region 2 is everything above this line. Yes, it will be region 1. Is that clear to all of you? How do you find it? You can substitute a point in region 1 and check whether this inequality satisfies. Okay, you can substitute a value, one of the points in this region and check whether it satisfies. Okay, and if you put a point in the region 2 and put it into this equation, you will find that it does not satisfy. Okay, so from that you can see that the region where this y less than or equal to u minus x is this region y. So this is the area which satisfies this inequality. This is the region. Okay. I hope that is clear to all of you. Now let's find the area or the region or the limits of x and y in this region. Okay. Since we are going to develop or derive all these proofs integrations with respect to y, okay, we'll think about x. We'll give the freedom for x to move along this axis from negative infinity up to plus infinity. Okay, so that means I can move this line along the x-axis all the way to the negative infinity up to positive infinity. So my x is going from negative infinity up to positive infinity. So it's like you are now think about this is a slider. Okay, you can slide this line along the x-axis to the left or to the right, negative infinity up to plus infinity. When you do that, now what will happen to y? What are the limits of y? Where can y go? Now, when you move x to the negative infinity, where will y stop? Up to which position y can go? You'll see that it can go up to negative infinity. Okay, it can, okay, when you move this one, it can go up to negative infinity, but it will stop at some point. What is that point? Okay, it should stop. Okay, always it should stop at the upper limit, which will be negative x minus, negative x plus u. Why is that? So because y should be always less than u minus x. See, okay, y can be any value to the left. The lower limit can be negative infinity, but it should be always less than or equal to u minus x, or in other words, negative x plus u. Okay, is that clear? Right. So we are fixing x. Or we are thinking that the line can move along the x-axis to any without any boundary. When you do that, y can only move from negative infinity up to negative x plus u. Okay. Right. Now we have found the region of y. Okay. So we are going to do this with respect to y. Okay. So we'll do these steps one by one. After we figure out the region, what is our second step? You have to find the CDF of u. Okay. That is by integrating the joint density of x and y. Shall we do that? So our first step is done. We have found the regions of x and y, or actually the region of u in this case. Okay. So let's try to find the PDF now, starting with the CDF. So what will be the CDF u? That will be FUU. According to the definition, that will be the probability that capital U is less than or equal to u. But our u is now x plus y, should be less than or equal to u. Right. So if you use, if you want to find the CDF, you have to integrate the joint density, okay, like this. And the support should be x plus y less than or equal to u. But we found that, okay, we found the limits for both x and y. So our outer limit is x. X will go from negative infinity up to plus infinity. See, right? X will go from negative infinity up to plus infinity. Meanwhile, y will go from negative infinity up to negative x plus u. If you want, you can write u minus x. That's fine. Okay. So is this clear up to now? Right? How you find the region and how you get the CDF? Right? Now, this is the proof. When you are doing actual examples, you will know the joint density of x and y. And sometimes the limits of x, okay, although we give the freedom of x to move from negative infinity up to plus infinity, depending on your example or the question, if x is uniform, it will be from 0 to 1. Okay, it will be from 0 to 1. So likewise, this limit of negative infinity to plus infinity will change according to your exact question. If x is a normal distribution, it will remain at negative infinity up to plus infinity. If it is an exponential, x will go from 0 up to plus infinity. Okay, likewise. Okay, so you have to keep that in mind. And y will go anywhere from negative infinity up to plus x minus minus x plus u. But again, if y is exponential, the lower limit of y will be 0. If y is a normal distribution, it will be negative infinity. Okay, so likewise, you will figure out the exact limits of x and y depending on the question, and the function f, x, and y, the joint density of f of x and y, depending on the question, you will find a certain function here. Okay, certain equation or certain expression will be there. Okay, since this is the proof, I'm using the notation. This is the joint density of x and y, fxy. Okay. Right. Now, in order to do this integration, we have to use the change of variables. Okay, because now integrating with these type of complex limits, we don't recommend it. Okay, so we can go for a simple change of variable format. And I'm sure now you are in second level. You have done some mathematical courses, calculus courses. So you know these change of variables. So if you have done mathematics, the physical sciences for A level, you already know how to do the change of variable in integrations. Okay. So this is what we have to do. Now our complex limit is negative x plus u or u minus x. Okay, so we are going to change this u minus x to a simple form u. Okay, because u is our target variable. Okay, now how do we do that? This is the substitution we are going to use. Now, identifying the correct substitution is also a kind of an art. You get it from practice actually. You need a little bit of creativity to figure out these substitutions that comes with practice. And by seeing similar type of questions and integrations again and again, you will practice this. You have to do these substitutions so your integration becomes simpler, not further complex. Okay. So I'm going to use this substitution v to be y plus x. Why I use this is in order to simplify our integrations. Okay. And you'll see why this was chosen. Okay. So if I choose v to be y plus x, y will be what? Y will be v minus x. Okay, just change the algebra. If you take y, this will be v minus x. Okay, and then if you do the derivative, dy will be du. Sorry, dv. This is why you know how to get this. I'm not going to explain all the smaller steps when you do the substitutions, how you change these derivatives. Okay. Now let's get the limits. If y goes to negative infinity, now our y is from negative infinity up to negative x plus u. If y goes to negative infinity, then what will happen to v? Where will we go? If y goes to negative infinity, okay, x is another number, so negative infinity and x, we will also go to negative infinity, right? Is that clear? When y goes to negative infinity, now look at this equation. When you set y to negative infinity, that is a very large number. If you add a value x, it's not going to change. It will remain at negative infinity because infinity is a very, very huge number compared to any value of x. X is, think that x is just a number, okay, that you add to infinity. Okay, so it is nothing doing. So we will also go to negative infinity. Now, what is the other limit of y? Negative x plus u. So when y goes to u minus x or minus x plus u, then what will happen to v? Can you find it? Where will we go? Substitute y with u minus x. Where will we go? If y is u minus x, we will go to where? Well, I already have the answer. It will go to U. Yes. Now you can see why I chose y plus x. Why? Then our random variable y, the limits of y, now it will be from now very simple limits. Now our new random variable is v. It will go from negative infinity up to u. So rather than this complex u minus x. Okay. Now shall we do the change of the variable? So what will happen to our FUU? We haven't done anything to x, so it will remain from negative infinity up to plus infinity. Now instead of y, we are changing it to v. So our v will go from where? Negative infinity up to u. Now it is very simple, but make sure you change the variables of this inside accordingly. Now what will be the change? We haven't touched x, so x will be there, but instead of y, what should we write? Instead of y, what should we write? If v equals y plus x, y will be v minus x. So instead of y, we have to write v minus x. And our variable dy, see dy should be changed to dv, and this dx will remain as it is. Okay? Is that clear? How we changed the variable, how we changed y to new variable v. So our limits are now very simple. Okay. So we are moving on to the last step, which is third step, step 3. We have to find the PDF of u. How do you do that? That will be by differentiating our CDF with respect to u. Right now, our CDF is this double integration. Okay. The CDF is this double integration. And again, when you do exact questions, you will end up with the function here. Okay, you will end up with the function here, and that is the function you will differentiate. But with the proof, we are doing it with the notation, and your final answer is very, you'll see that how nice it is that you can use it straight away when you do questions. Okay, because this is a theorem that we prove, so you can use the result. Okay. So let's do the differentiation. So d over du, what is our CDF? Now this double integration. So let's write it. If you have any place unclear, please stop me. Okay. I hope I'm not fast. Okay. So this is our differentiation. Now this differentiation is with respect to u. Okay. So you don't see any u in x. X is independent of that. U is only available in the second integration. So let's take our x outside. Okay, why are we taking x outside? Because it is independent of u, right? So nothing will happen to this integration because we are doing the integration with respect to u. So you can take it to the inside of this integration. Okay, so our inside integration is, sorry, not y, v. V goes from negative infinity up to u. Please pay attention. If I make a mistake, correct me, okay? Because with these letters here and there, it's very easy to have to make mistakes. So pay attention carefully. Right? Here's my outer integration. Right? Now, what are we going to be do this with differentiation? Now, what do you see? You have a differentiation and an integration. These are like the complements, right? So it is like when you have a product and the quotient, they cancel out. When you have the plus sign and the negative sign, they cancel out. So likewise, in calculus also, we have a certain theorem. Okay. According to that theorem, it's not actually the cancellation, but that is according to the way we apply that theorem, your derivative and the integration, they vanish because they are like the complement. The integration will be taken over by the derivative or the other way around. So the derivative and the integration, they will vanish away. Okay, it's not like canceling out, but that is the theorem. Can anyone remember what is the name of that theorem? Anybody who can remember that theorem? When you have d over dx and integration x, they cancel out and you end up with just the function there. Have you heard about this? Okay, I think I got the answer. Leibniz integration. Okay, that you are thinking too much, but I like it. Okay, you are very up to date, Akalanka. Thank you very much. So, but I'll give the simplest name of that, FTOC. Akalanka, can you figure this out? What is FTOC? I don't say your answer is correct. I don't say you are wrong, but this is the name that we usually use with the theorem. That is the fundamental theorem of calculus. Okay, FTOC is the, I hope you can remember now, fundamental theorem of calculus. What will happen? The integration will be taken over by the derivative, and what will happen? Both of these will go away and you'll end up with only this inside function. Okay, but when we do that, you have to make sure you change the, yes, you are right. You are right, Akalanga. Yeah. So what we do is, you have to make sure your variables inside this function are taken care of by this cancellation or this taking over. So what should we do? X, we are not going to touch it. X is there as it is. Okay, so this minus x is there. This dx is there. But what will happen to this v? Okay, what will happen to this v? So you are doing this v, okay, with respect to this u, so that u should go here. So at the end, you end up with the PDF of u to be the integration of fx, or the joint density of x and u minus x. Okay, and x is going from negative infinity up to plus infinity. So this is the final outcome of the of our proof or our steps. Okay. Now, if you look at this final answer, it is very simple. It is only depending on x. It's only depending on x and u. Okay, so u is what we need. Okay, so very easily you can use this outcome and get your the answers for any density function of x and y. Okay, since we did all the integrations with respect to y, right, from the very beginning, we did it everything with respect to y. Okay, we got the region with respect to y, okay, and everything. Okay, and x was never touched. So therefore, our final answer is in the form of x and u. So I'm not going to make you confused, but this is something that you should keep in mind. You can do this with respect to y also and find your final answer in y and u. That is also possible. In that case, you have to write everything with respect to x, not as y less than equal to u minus x, but in the other way around, x is less than or equal to u minus x. But you know, we are very familiar with writing equations as y equals mx plus c type. So that is why we use this y less than or equal to u minus x. Okay. So when you do that, you'll end up with your final answer to be of this format. So this is what you should keep in mind of, right? I recommend you should know these three steps. Okay, not like by heart it, with the explanation and with the understanding. Okay, so how to get the region, how to get these limits. Okay, not in by heart, Okay, කටපාඩම් කරලා නෙමෙයි. Because if you change these letters, if you do this by heart, you'll in a big trouble. And then when you have to substitute x and y with actual equations, you will be in trouble. Okay, ඒ නිසා කටපාඩමෙන් නෙමෙයි තේරුම් අරගෙන මේක මතක තියාගන්න මේ steps ටික. Okay, sometimes in examinations there will be a question to prove this one and then use the answer to do the question. Okay, so maybe you can remember only the final answer, okay, and then you can use it, but the proof you should know. Again, not with the letters, because u minus x goes to u, v is y plus x. Don't do that with the by hearting. Okay, කටපාඩමෙන් එපා. තේරුම් අරගෙන කරන්න. Because if I give you these letters with some other, say w and z and some other letters, you will be in a big trouble if you do the by heart. Okay, so therefore I always recommend understand this and then try to draw this proof by yourself. Okay, there, in that case, for whatever the function x and y, whatever the distribution you get for x and y, you will be able to figure this out very easily, okay, without a doubt. Okay, now do you have any question up to this these 3 steps? Because I'm going to do the subtraction also, okay, because they are very similar, and after that we'll do some examples. Okay, okay, so let's do the subtraction also, and you'll see how similar they are. Okay, and since now you know these 3 steps, we can do this very quickly. Okay, so we'll do the second one. Now our u is x minus y, right? So let's follow the same steps. So I recommend you take a piece of paper, your pens and pencils, and do this with me, right? So it will be a good practice, and if you make a mistake, you will figure it out. If I make a mistake, you also catch it, right? So what do we need to do? We want to find the PDF of u. Now our u is the difference. What is the first step? You have to find the region where u is less than or equal to u. Now what is our u? Now we have x minus u. Sorry, x minus y is less than or equal to u. Okay. Right, so like this, we have to find now x minus u less than or equal to u. Right, so similar to the previous case, let's take the equation. Okay. Okay, but it's better to get rid of the negative sign, right? So what do we have? Y is greater than or equal to x minus u. Okay, take this y to the other side, take the x and u to the other side, so I'll end up with y greater than or equal to x minus u. Okay, now can you draw the region on your x and y, the Cartesian plane? Try to draw the graph on the xy Cartesian plane. Now what is the slope? If you think about y equals x minus u. Now the slope is 1 and it is positive. So you know how to draw the line, increasing function, increasing. And then your y-intercept is negative u. So how will it look like? Like this, right? So here's our intercept. So what will be the two places where it crosses? Maybe I should draw it in a better way. Okay. And what is the region? You have to have y greater than x minus u. So you'll find that the region is this upper side. Okay. So if y is x minus u, what is x? X will be y plus u. Okay, you will need this when you take the limit. Okay. Now this time we are going to do everything with respect to x. Okay. The previous one, we chose to slide this line along the x-axis and gave the freedom of x to change from negative infinity up to plus infinity. Now in this case, we are doing it for y, okay, because in that way, the equation is easy, but you can do it with respect to x, okay, no problem. You can do it with respect to x, but to make this easy for you to understand, I'm going to do it with respect to y, okay. So I'm going to fix y. So y can go from negative infinity up to plus infinity. The coordinates, am I? Okay, yeah, sorry. Thanks for showing it. I'll correct it. So this when x is u, y is 0, and when y is when x is 0, y is negative u. Sorry. Okay, it's correct, right? I was checking whether you are sleeping or paying attention. Now don't laugh. Okay, so what are the limits? So I'm going to fix y. Okay, that means I'm going to give the freedom to go from negative infinity up to plus infinity. If I do that, what are the limits of x? Okay, so x can go any way further to negative infinity, no problem. But where should it stop? Where should it stop? It should stop at y plus u or u plus y. Okay, so those are the limits of y and x. Now we can write or we can move on to the second step. Is this clear up to this one, up to this limit? Okay, right, here's the second step. We are going to write the CDF of u. We start with the definition. U is x minus y. Okay, so that will be the double integration x minus y less than or equal to u, the joint density of x and y. Okay, now since I am fixing y, okay, I'll write y as the outer integration. Okay, so you can see the difference from the previous one. The previous one, we wrote the outer integration to be x. Now in this case, we have given the freedom for y. So y will be the outer integration, negative infinity up to plus infinity. And our inside integration will be from x negative infinity up to where? Y plus u. And inside we have the joint density of x and y. Inside we have dx, outside we have dy. Make sure you write it in the correct order. Okay. Now, if you chose to give the freedom for y, you have to make sure you write the limits accordingly. Then x will be outside and y will be inside with the correct limits. Okay. Uh, so you can try it. Is the other way around hard? Not hard. I want to make this consistent throughout the proofs. That is why I'm using this, but you can try it. Okay, it's not going to be hard as long as you maintain the change of variables and the signs in the correct way, in the correct limit. You can do it. Okay, I'm not saying it is very hard. You can do it. So try it. Okay, just try it, and if you refer online material, you'll see these both ways. Okay, sometimes some examples use x to be fixed, some examples use y to be fixed. Okay, so you'll be able to find all these examples and proofs out there, even in textbook. It is not hard. I just wanted to make these proofs very consistent. That is why I'm doing in this way. Okay, so you can actually do this by yourself and see how you can end up with the answer. No problem. Okay, I don't want to say it is hard. It is more consistent when I do it in this way for your the matter of for the your note set. Okay, so that is why I'm doing this. Right. So you are very welcome to try it by yourself the other way around. Okay, no problem at all. Okay, so let's see what will happen. Now we wrote the integration, right? So we are here. We are here. Now let's do the change of variable. Okay. Can you also try it, the change of variable? What do we have to do? You have to get rid of this complex y plus u. Get rid of with a simple one. Okay. So I want to make this u plus y reach to u actually. Okay. So that should be the final outcome. So we do the substitution. So I'm going to let v to be x minus y now because we have a plus sign here. In order to cancel it out, we get x minus y. So if we take vx minus y, our x will be y plus v. Okay, this will be y plus v, and the dx will replaced by dv. Right? So shall we find the limits? What will happen to v when x goes to negative infinity and y minus y plus u? Okay. So when x goes to negative infinity, what will happen to v? Okay, it's just a negative infinity minus y, so we will also go to negative infinity. And when x goes to y plus u, where will we go? When x goes to y plus u, y will cancel out and v goes to u. So that is why we chose the negative sign. So this cancellation in order to get this cancellation. Okay, now we have simple limits. So like we did in the previous case, let's do this substitution. So what will happen to our fu? We haven't touched y, so it is still there as it is. And now our x will be replaced by v. It will go from negative infinity up to u. Okay, and what will happen to the inside? We have x minus y, but our x is now what? Y plus u. So we replace x with y plus v, and y will be there as it is. And our dx will change to dv, and outside dy will be as it is. Okay, so we are almost done. What is our last step? We have to do the differentiation. Again, we apply the FTOC. Now remember, when you do actual examples with actual distributions, depending on the support of y and x, you'll have different limits. As I mentioned, if y is exponential, the limits of y will be from 0 to infinity. Okay, so likewise. Okay, again, you can see that the outer integration is independent of u. So like we did in the previous case, we'll take the derivative inside. We going from negative infinity up to u. So what will happen to this one? Okay, it's according to the fundamental theorem of calculus, you'll end up with the outside integral as it is. But here, so your v should be changed to this u. So you'll end up with function, the joint density of y plus u and y dy. So here's our final outcome. Okay, so this is the density function of u when u is the difference x minus y. Okay. Any questions so far? Now, what do you think? Where will these type of transformations be useful? Okay, if you use the other way around, your final answer will be in x's, not in y's. Okay, your final answer will be in x's. X will be from negative infinity up to plus infinity. And inside this, the joint density, it will be in x's and u's. It will be in x's and u's and dx. Okay. You will not get this exact way, but depending on the variables you use, it will be then in x's, not in y's. Okay. Your final answer will be in with respect to x, not with y. Okay, Akalanka? Right? Right. So you will not see y plus u comma y, or the joint density of y and u will not be your inside function. It will be in x's and u's. Okay, so it will be a little bit different. Right? Okay. And the same will happen with the plus. If you do it with respect to y, you'll get your final answer, this one, joint density of y and u. Okay, so it will be a little bit different, right? Not the exact same. But when you do this with exact functions, that will not be a problem. Okay, these are just letters, right? These are just letters. X can be Y, X can be Z, X can be W, U can be V, U can be Z, U can be W, any way. Okay, this is just the formation. Okay. Any other question? So let's do an example now. If you are wondering why we are doing these things, where are these type of proofs are applicable? Now, if you think about statistics itself, okay, if you think about statistics itself, there are situations where we have to add up two independent or maybe dependent random variables. Sometimes you end up with, in your research, you'll end up with two different random variables, okay, and you have to add them up. Say, for example, you are thinking about the distance from in between 2 points. Now think about two places, okay? You're thinking about the distance between two places. So what will be the total distance? You have to add the distance from point A to B and from B to C. Okay, now the distance from A to B, okay, that will have a certain function. Okay, it can be a linear function, we don't know. It can be a quadratic function, a polynomial, right? It will be a certain function. And the distance from B to C will be another function. Now, when you are going to add that, if you know the functions, and if you want to find, say, the probability of how this distance change, okay, when you move these point A, B, and C along X and Y axis, what will happen to the distance? Okay, what is the probability of these changes of these distances? So you will use these type of functions. Okay, especially in simulations, you will end up with these type of applications. Now, if you think about graphical recognitions, right? Now think about the facial distances. You think about the distance from to the left and the right eye, and in between you have the midpoint of the nose, the starting point of the nose. So you measure to the beginning of the, or the midpoint of the left eye to the right eye. Okay, when you are doing facial recognitions, you do these type of measurements. Now, when these points change, how these distances will change? Okay, that will be sometimes the sum, sometimes the difference, and sometimes it is the quotient. That is what we are going to learn later, right? The ratio between the distances. Okay, like in the facial recognitions, these type of applications are very, very useful. Okay, if you know the distribution of these lengths, okay, these ratios, that is how you do these approximations. Okay, approximations are always the probability, right? Now, if you think about the theoretical aspects in statistics, take the most widely used distribution, the normal distribution or the standard normal distribution. If you add two normal distributions, what will be the new mean? What will be the new variance? Okay, depending on that, you can calculate the probabilities or the behavior of the distribution. Okay, if you add two normal distribution, the sum, is it also a normal distribution or not? We want to find it out. Or if you add, or if you subtract two independent normal distribution with different means, different variance, what will be the final outcome? Is it again a normal distribution? Okay, so if you can find this FU, okay, so you will know by by looking at the equation, you will see, okay, this is the normal distribution, this is the new mean, this is the new variance. If you add two uniform distributions, one is from 0 to 1, another one is from 1 to 10, when you add these two distributions, what will be the final one? If then, what is the mean of the new distribution? What is the variance? What is the median? You will be able to figure those out when you know these outcomes. Okay. So these are very important in practical situations also. Right. So if you look at applied mathematics, okay, these are very, very useful. Sometimes you even do not know that is what you have used when you look at the already developed applications, but the inside theory will be these transformations. Okay, you only see the outcome, the estimated values, but what is going inside the machine, the theorems, the numbers, they will follow these type of calculations. Okay, this basic will be these calculations. Okay, shall we look at an example before we do? I don't think I'll be able to do the quotient and the product today, but let's look at an example. Okay. So we have X and Y identically independently distributed random variables with exponential lambda. Okay, so what is your distribution? X is also exponential with lambda, Y exponential with lambda, and they are IID. What is the meaning of IID? Identically and independently distributed. Identical means it is clear, it's identical, same lambda, same ratio. Independent, that means these two are not depending on each other. The outcome of one event from X will not depend on the outcome of an event from Y. So they are independent, identically distributed. And what is the other information that you know from independency? The joint density of X and Y, what is it? That should be the product of the marginals. So this is what you get from the independent information. When you see two random variables are independent, the first thing that you come to your mind is that the joint density is the product of the marginal. What is why it is important to understand the joint density? If you remember, all these derivatives, we start with the joint density. See, start with the joint density. Okay, we start with the joint density. So you should know the joint density of X and Y. If it is given, it's fine. If it is not, you have to derive it, right? You have to derive it. And whether they are independent, it's very easy. It is just the product of the marginals. Okay. So we start with writing the marginal densities, Fx. Okay, this is the exponential distribution, lambda e to the power negative lambda x. X will be from negative from 0 up to positive infinity. Y the same thing. So what is from 0 up to positive infinity. Now, what is the alternative form of exponential density? What is the other alternative form? 1 over theta e to the negative x over theta. So this is the other alternative form. Okay, that is the rate parameter. The mean is 1 over theta. So this is the other way of writing it. Okay. So if you refer textbooks or online materials, sometimes similar questions like this derive the sum of two independent random variables. You will see this example a lot if you search the internet. Sometimes some people use this formation. So don't panic. It's the same thing. There is the alternative way of writing the exponential distribution. Lambda is the rate parameter, theta is the mean. Okay. So it is, don't panic. It's the same thing. It's the same thing. So your final answer will be in this same format if you use the alternative way. Okay. Right. So we know the marginal densities of X and Y. Right. Therefore, you can find the joint density. Right. Easily you take the product. So lambda and lambda, you will get lambda square. And the base is E. You have negative lambda X and negative lambda Y. When the base is the same, you can add them together. So negative lambda, you take it outside and add X plus Y. So this is our joint density of X and Y. Okay. Is that clear? Right. So we can write the joint density like this. They are independent. X is greater than 0, Y is greater than 0. Right. So let's do this in all steps. So here's my first step. Right. Now, since both X and Y are positive, these are exponential, so you don't have to worry about the negative lines. Okay, always X is greater than 0, Y is greater than 0. So you can stop your region from here, right? So that is why I mentioned you have to be applicable according to the question you do. Okay, so we do the same thing like we did in the previous case. Now, can you remember this is our final outcome, right? So I'll go back to the proof of X plus Y. Right? Here's our final outcome. That is what we have used straight away here. Okay, because we have already done the proof, right? So you can use that one here. Fx comma u minus x. Okay. Now look at this function that you see inside x and u minus x. In our original proof, what do we have? right? So this is what we have. Now, if you look at our function here, the joint density, okay, of x and y, instead of y, what should we do? Instead of y, we have to put this u minus x. Okay. So if you look at our joint density, I'll write it here. So it's easy for you to refer. Our joint density fxy is lambda square e to the negative lambda x plus y. Okay, so we have to rewrite our x comma u minus x form of this x and y. So what do we have to do? Instead of y in our joint density, this y should be replaced by u minus x. Very simple, right? So wherever you see y, replace it with by u minus x. Y is in, or you see y only in this exponential, this term. So we keep lambda square as it is, e to the negative lambda, and within brackets you have x, and instead of y, you replace it with u minus x. That's it. And what will happen to the range? What will happen to the range? X will go from 0 to infinity, but it should stop where? See, it should stop at u, right? So if you slide this line, okay, and here's the limit. Okay, this is how you get the limit. Okay, so x will be less than or equal to u. So this will be our new unit. Okay, so this will be our new unit. See how you have to do the change of how you get the limit, because y is greater than 0, y is our u minus x. Okay, and that means x should be less than or equal to u. And the lower limit of x is 0 because it is the exponential. Okay, now you have to simplify this term. In the proof, we stop from here. But when you have the exact equation, you can very easily do this integration. Lambda is the constant, take it outside. X going from u to 0 to u. This x will cancel out. You'll end up with simply e to the negative lambda u. Okay, e to the negative lambda u. And this is with respect to x. So you don't see any x in this term. So it will be simply lambda square I to the negative lambda u times x, and evaluate x from 0 to u. And when you do that, you'll end up with lambda square I to the negative lambda u simply u. So you can write it nicely in this formation. Okay. And the u is greater than 0 y. U is x plus y. X is also greater than 0, y is also greater than 0. When you add them, u is also from 0 up to infinity, or 0 otherwise. So here's this is the final answer, or the density function of x plus y, where x and y are two independent exponential distributions. Okay. Is this clear to all of you? So although the proofs are maybe complicated or it is long, but when you do them with exact examples, it is not that hard. Okay. If you know how to get the limits correctly, that is it. Okay, so can you use this equation directly without deriving it? You can, but usually in exams, I ask you to prove it. Okay, so know it. Because according to the learning outcomes, we have to check with this course. We have to check whether you know it. Okay, the thing is, if I have used different letters, you should know how to write it. So usually in exams, I ask you to prove it. But actually you can use it straight away. Okay, even in tutorials, you can straight away use this because we have done the proof and it is a proven result. It's okay in tutorials. Yes, you can straight away use it, but make sure you get the correct limit. Okay, draw the graph. It is always, I always recommend you draw the graph according to the given question and find the limit. But this equation you can just straight away apply it, no problem. Okay. But in exams, uh, there's a very high probability that I ask you to do the proof. Okay. Right. Now, what is this distribution? Do you know this distribution? Can you find it out? Okay, so I'll leave it to you as an example whether this is a closed form. Closed form means is this a non-distribution? Okay, so see whether you can find whether this is a closed form of the distribution, any well-known distribution. Okay, try to find it out, right? And then I would like to do the uniform distribution because it is, although uniform is simple, when you add two uniform distributions, the final outcome is a very nice, different kind of a distribution. Okay, so I would like to do it. It will take some time with a lot of explanation, so I'm not going to do it today. But if you want, you can search it. That will be our next example. If X is uniform, 0 and 1, Y is also uniform, 0 and 1, and X and Y are independent. This U is for uniform, okay? What is the distribution of X plus Y? Okay, there are a lot of tutorials available. Okay, some have explanations, some not. I will explain this in the next class, how to get the sum of two uniform distributions. In addition to that, you can search and refer textbook books. There are proofs on how to derive the sum of two standard normal distributions when they are independent. Some of these tutorials will use another method that we are going to learn in our next section. But it will be a good practice if you refer these things. Okay. At any other question? We have to. Okay, I want to answer Janit's question. Give me a minute to get the document from the previous class. Okay. Okay, so Janit, your question was, what was the limit of example 3.3, right? So we had fx to be e to the negative x, which is x is exponential, and our y was ln x, right? So the limit of x, when x is 0, what will happen to the ln x? What is ln 0? It goes to infinity, right? And when x goes to positive infinity, ln of infinity is also infinity. Okay, so that will be, so you'll end up with y from negative infinity up to plus infinity. Okay, so this is the limit of y. Right, so in your final answer, let me get, so your final answer was this one, right? So y will be from negative infinity up to plus infinity. Okay. Any other question? Okay, so with that, I will stop the lesson for today. And try to do the other way around also for these proofs. Okay. And then try to find what will be the density and when x and y are uniform. Anyway, I'll do it next time, but you can also try to find it. And also what will happen if x and y are normal distributions or standard normal, what will be the final outcome. Okay, these are very interesting results. Even if you have many random variables, okay, 3, 4, 5, n number of random variables independent, what will be the final answer? Okay, this will be very nice findings. Okay, you can refer to them and get an idea. Okay. Madam, this are distributions used to create hash functions. Do you mean by hash functions the functions which are not of closed forms, like a non-distribution? I think that's what you're asking. It's like you don't always get the these distributions, the answers, they may not always be the closed forms. They may not be the exponentials, uniforms, betas, gammas, like the non-distribution, but there can be functions of unknown forms. I mean, not unknown, not the closed forms. Yes, there can be functions where you can't give a common name. That is possible. Yes. I think that is what you meant by hash functions. Any other question? Okay, I like this class. Compared to your seniors, you are very good asking questions. When we had the face-to-face classes, they are very quiet. Okay, another question, Akalanka. When you have the product, yes, the graphing is a hyperbola. You're correct. The graphing is a hyperbola, and I think you have already seen it in the notes. But the derivation is not that much hard. Okay, although you see that the area or the region is different than these linear functions, the derivative now it's not that much hard. It's the same level of these sums and derivative sums and differences. Okay, even the quotient, right? Okay, so very interesting class. Thanks for all your participation, and I hope you'll keep that in your future lessons also. Okay, then I'll upload this document and also the video lecture, and I have already uploaded part 1 of chapter 3 and even all the other chapter 1 and 2 videos, so you can refer to them. And I will upload today's video and today's lecture notes also. So if you do not have any other questions, shall we finish for today? Okay, so all of you stay safe and hoping to see you next week.